By May of 2026, much of India was sweltering under an intense, lingering heat wave. Relief usually arrives with the southwest monsoon. Between June and September, these seasonal winds deliver nearly 70% of the country's total annual rainfall. Over 60% of Indian farmers grow summer crops entirely on these rains. Without irrigation, those clouds represent their only chance for a successful harvest. But ahead of the 2026 season, authorities issued a stark warning. The monsoon was expected to fail. Forecasters projected prolonged dry spells and crippling heat waves, leaving millions of acres without water. The source of this meteorological threat sits 10,000 miles away, submerged in the depths of the central and eastern tropical Pacific Ocean. India's survival this season depends on the behavior of a cyclical ocean engine, known as the El Niño Southern Oscillation, or ENSO. To understand why the Pacific dictates global weather, we start with the ocean's normal state. In a standard year, strong trade winds act like a conveyor belt. They push warm surface water westward, pooling it against the coasts of Asia and Australia. This westward push allows cold, nutrient-rich water to well up along South America, cooling the eastern Pacific. This continuous loop, where ocean heat generates wind and pressure, is the Walker circulation. Every 3 to 7 years, this engine breaks down. The vital trade winds weaken, losing their ability to hold the warm water west. The massive pool of warm water sloshes eastward, migrating back toward the Americas. Even a small thermal shift of 1 to 3 degrees Celsius is enough to disrupt the global atmospheric system. The physical displacement of this heat fundamentally rewires global pressure. By moving the warm water, the ocean dictates exactly where rain clouds will form and where they will vanish. As the warm water moves east, heavy rain clouds follow the heat. This shift brings catastrophic flooding to the coasts of Peru and Ecuador, turning arid landscapes into underwater flood zones. But because the heat has left the western Pacific, it leaves behind a massive atmospheric void. This void creates a high-pressure system of dry, sinking air that parks directly over India. This air mass acts as a lid, flattening moisture levels and suppressing the formation of monsoon clouds. The climate can also swing to the opposite extreme, La Niña. During these phases, the trade winds strengthen and the eastern Pacific cools significantly. Historically, La Niña pools excess moisture westward, delivering unusually heavy monsoons and beneficial rains to the Indian subcontinent. The world recently emerged from a rare 3-year triple-dip La Niña. Now the Pacific is violently snapping back to the other side of the climate seesaw. By mid-May 2026, the present reality became clear. A massive reservoir of heat surged 150 meters below the ocean's surface. Statistical models now assign a 98% probability that a strong El Niño will take hold, persisting through the end of the year. A second factor is compounding the threat. The Indian Ocean dipole is also shifting toward a positive phase, further disrupting the flow of moisture toward India. The local consequence is inevitable. The second half of the Indian monsoon will weaken. This moisture failure will occur precisely when standing summer crops require water the most to survive. Cascading impacts include shattered agricultural yields, depleted drinking water reservoirs, and deadly heat waves offering no relief. A farmer in India and a fisherman in Peru are bound by these same invisible currents. It is a world where a mere 1-degree temperature shift in the Pacific is enough to reshape the lives of billions.